All right, I'm going to go first over the first one real quick because some people hadn't heard that one yet. We changed the 2 theta to theta plus theta, and we used our sine A plus B formula, sine A cos B plus cos A sine B. And A and B were both theta, so it turned out we had like terms here and we could add them together. So we're going to do the same thing for the next one, change it to cosine theta plus theta. So remember 2 theta is the same as theta plus theta. And we're going to apply your cosine A plus B formula from your sum and difference formulas. So cos A, cos B. So A and B are both theta. And then minus sine A, sine B.
Why don't you just changing it to cos squared theta minus sine squared theta?
Okay, so I want you guys, where are you getting that from, the cos squared theta minus sine squared? Okay, so what we're trying to do is we're trying to prove the double identities before we use them, so we're not using the new identities yet. All right, and Michaela, what was your question?
That was my question.
Oh, same thing, okay. Yeah, so we're proving them before we use them. So now I understand, because they look like they're one-step proofs if you use those identities, right? Okay, so we're using the sum and difference identities to prove them before we start using them. Now, cosine times cosine gives us the cosine squared. All right, so once you get to cos squared minus sine squared, we are trying to get rid of those sine squareds. What can you replace that with? 1 minus cos squared. So you can replace the sine squared with 1 minus cos squared theta.
Why?
So that's a Pythagorean substitution. I'll show you in just a sec. All right, let's see if I have I think I have my list right here. So to go from this step to this step, I changed sine squared to 1 minus cos squared. That comes from this list right here. Okay? All right. Now distribute your minus. So you're going to have a minus 1 but a plus cos squared. And now cos squared theta plus cos squared theta makes what? 2 cos squared theta. So I'm glad that you guys pointed out that these were on your calendar, because that's exactly what we're proving. We're proving the ones on your calendar. And you'll notice for cosine that there are actually 3 different formulas. Cosine 2 theta has 3 formulas. You can use any of them. Okay? Sine 2 theta has just 1 formula. Tan 2 theta has just 1 formula. But for the cosine, you can use any one of the 3 choices. So for as far as memorizing, you don't have to memorize any of the new formulas. The ones that you want to memorize are reciprocals. Whoops, where'd they go? Reciprocals, quotients, and Pythagoreans. That's it. Okay? The rest of them will be given to you. All right, tan 2 theta. So we're going to change your 2 theta to theta plus theta. And then you're going to apply your tan A plus B formula, which is tan A plus tan B. Over 1 minus tan A tan B. All right, so this is a good algebra review. Tan theta plus tan theta makes what?
Is that one of the sum and difference identities?
Yes. So it's the second to last one there on the list. So this makes 2 tan theta. Good work, guys. And then 1 minus, if you do tan theta times tan theta, what do you got? Tan squared theta. Michaela, I'm glad you said it that way. Tan squared theta. Very nice. And that's exactly what we want to write here, too. Okay. Any questions on page 1 before we turn to page 2? We're going to try to start setting up page 2. Yeah. All right, so guys, I'm going to pause here for a second, but if you are looking ahead at page 2, the way to start is to draw a picture of angle A and draw a picture of angle B. And the information for drawing the picture is described right there. All right, so on the next side, did you pick a quadrant for angle A? 1, 2, 3, or 4? 3? Yeah, that's good, because it's between pi and 3 pi over 2. So you need to draw your triangle in the third quadrant. It has to have a right angle with the x-axis. So that's the kind of triangle you're drawing. I don't care how long you make the sides. I don't always draw these to scale. Angle A, though, is going to be at the origin. That's angle A. And tangent is opposite over adjacent. So opposite of A is 4, and adjacent with A is 3. All right, what's wrong with my picture? Okay, I heard 2 people say it needs negatives. Where? Negative 4 and negative 3. All right, do I still have a tangent of 4/3? Good, because the negative over negative cancels. How about the hypotenuse? Should that be positive or negative? The hypotenuse is always positive, no matter what. Okay? Always positive.
What's the first, what's
This?
the other one?
This?
No, not the one above it.
A?
The line? No. So there's 4 lines. This one right here. What value is that? Like the bottom one's 3 pi over 2. What is it?
Oh, so this is 0, and this is pi over 2?
Okay.
Is that good? Okay, sorry. It's 0, it's also 2 pi. Like, it's 0 at the beginning, and then you go around, it's 2 pi. Sorry about that. All right, so how about the hypotenuse, guys? Do I need Pythagorean theorem, or do you know what it is?
5.
I heard 2 votes for 5. Anybody want 5?
5.
Avi, do you like 5?
Just
5? For the hypotenuse?
Yes.
Okay. So it's a 3, 4, 5 triangle, but if it wasn't, you could do Pythagorean theorem. All right, so now that we have all the information about A done, we're going to do B. Angle B is between 3 pi over 2 and 2 pi, which puts it in what quadrant? 4. Good. 3 pi over 2, 2 pi. It needs to connect to the x-axis with a right angle. All right, secant's the reciprocal of what? Cosine. Cosine was adjacent over hypotenuse, so this is hypotenuse over adjacent. So hypotenuse is 13. That's my B, which makes this my adjacent. All right, does it make sense for those numbers to be positive, 5 and 13?
Yes. No, not yes.
Yes? Okay. Yeah, I think so too. All right, and then looking for the missing value. Do you think the missing value should be positive or negative?
It was a hypotenuse over adjacent?
Because cosine is adjacent over hypotenuse, and secant is the reciprocal of cosine.
Oh.
All right, so Pythagorean theorem, guys, if you know what it is, that's super. You can write it down, but don't ruin everybody else's fun. So 5 squared plus y squared equals 13 squared. Y squared equals 144. So remember that when you solve with a square root, you get plus or minus 12. You have to decide which one makes sense in this situation. Minus 12, good. Okay, so now you have a picture for A and a picture for B. Now you can evaluate the problems below here. If it says sine A plus B, you don't just add the sine of A and B because we know there's no distributive property. You have to write the whole rule out. So sine A plus B is sine A cos B plus cos A sine B. Write the whole thing out. Sine A cos B plus cos A sine B. This is like your map for solving the problem, so don't skip that step. Look at your neighbor who's ignoring me and tell them to write it down. So write down the formula for sine A plus B.
Cos this row
Yes.
plus this row. Cos. Oh wait, this is the word for letter D.
You can do it that way, but you can also use, now that we've proven your cosine 2b formula, you can use your cosine 2b formula.
Okay.
But then what you want to do now is you need to find numbers from the picture.
Okay.
So you can put numbers on. Okay.
So if it's -5, does it become minus? Or no?
I think you're ahead of me. Give me 1 sec.
Is it the values that we found?
So guys, now we're going to fill in values from your picture. Sine of A is opposite over hypotenuse. So -4 over 5. Sine of A. Cosine B, you got to switch pictures, guys. Cosine B is over here, and I want adjacent over hypotenuse. All right, cosine of A. Go back to A and find the cosine. Adjacent over hypotenuse. And sine of B, you got to go back to B, and you're going to do opposite over hypotenuse. No. Okay. The more you practice these, the better you're going to get, because the most common triangles that they use are 3, 4, 5, and 5, 12, 13. All right, does anybody know why I don't want to cancel out these 5s here? I mean, I could cancel them, but why would that not be a good move?
Because the denominator would change.
The denominator would change, and now I won't have a common denominator. So I'm not going to cancel them. I'm going to leave that as -20 over 65 plus 36 over 65. What's my final answer?
16 over 65.
Yep.
Such a big.
That's actually... Yep. Okay, so first thing I did was write down the formula, okay? Same formula from your formula sheet. Then, sine of A, I had to look at angle A and find its sine by doing opposite over hypotenuse. Cosine of B, I have to look at B and find its cosine, oops, it's up here. Find its cosine by doing adjacent over hypotenuse.
I understand all the fractions, just
Okay.
like the denominator and the.
So then I multiplied -4 times 5 to get -20, and 5 times 13 to get 65. All right, guys, I'm going to do D, and then I'm going to let you guys work on your own, okay? Cosine 2B. We get to choose which formula we use, guys. What do you want to use? Look at my choices here. 1, 2, or 3?
2.
I heard a vote for 2.
No, 1.
Okay. 1. Fabricio's the only one voting, so he wins. So on your formula sheet, you have 3 choices for cosine 2 theta. But Fabricio just chose this one for us, so we're going to do the problem this way. But at home, you get to choose your own, okay? So we're going to do cos squared b minus sine squared b. All right, so the cosine of b squared minus the sine of b squared. So guys, I'm using the new cosine 2 theta formulas. Now, let's look back up here at your b. The cosine of b is adjacent over hypotenuse. And the sine of b is opposite over hypotenuse. People think squaring a fraction is difficult, but it's not. You just square the numerator and the denominator. It's good to know the squares of 3, 4, 5, and 12, and 13. Those are just good numbers to know. So 5 squared? 25. 13 squared? Close? 9. Yep. Negative 12 squared? 144. And 13 squared is still 169. All right. Some people find subtracting a small number minus a large number difficult. You know your answer is going to be negative, so you could just do it backwards if you want. You could do 144 minus 25. What do you get? Negative 1, I think negative 119? Is that right?
Yeah.
Okay. All right, so we are going to stop there for now, and you guys are going to keep working on B and C, and then after lunch, we're going to go over those two, and then I'm going to check your homework at lunch, so put your homework on your desk, okay? Make sure your name is on your homework. You changed your spots, so I might not know who sits where, so write your name on your homework before you go.